Before we can explore integration testing, we need to understand integration itself. Integration testing is probably the most misunderstood concept in testing. Whenever I meet people in projects, I ask them what integration and integration testing means to them. I just get different answers. It starts and ends at different times and places and done by different people. It has different goals. It's not consistent out there. Perhaps this is because integration is all pervasive. I would argue that integration testing starts with the second line of code written. The programmer has to integrate the second line of code with the first line of code. It starts there. Integration ends when the last acceptance test is performed and passed. In this video, I'll argue that all testing after component testing is a form of integration testing. I'll also talk about integration in the small as compared to integration in the large. Then we'll be ready to talk about integration testing itself. It's convenient to think that integration is a process of software assembly and testing. The problem we have is software components aren't like car parts. Software doesn't have any shape or weight or size or dimensions. You can't hold it or touch it. It's thought stuff. Fred Brooks famously wrote this about software. The programmer, like the poet, works only slightly removed from pure thought stuff. He builds his castles in the air from air, creating by exertion of the imagination. Well, that's a kind of poetic way of putting the same point, that software isn't the same as steel and concrete. If you like, what we do when we build systems, we don't build software at all. It's not a good metaphor for how we construct software systems. Essentially what we do is we define, probably in a text file or a database, the location of various parts of the software that's been constructed by developers, and then tell the computer to take all these parts distributed across multiple systems maybe, to reference them all and to build an image, as it's called, of the system as a whole. Now, this isn't the same as putting a nut on a bolt or knocking a nail into a piece of wood. It's not something we can see except when we have the finished software product. We don't see the joins, if you like, except that the joins are being invisible, are difficult to get right, and it may take us hundreds or thousands of iterations of builds to actually end up with a complete system. We don't build software at all, and because of this, integration is error-prone. Now, essentially what we do is we build systems from smaller components. At the beginning, we have our developer-written and tested components, and these are essentially just lines of code. This is what you can actually see and maybe touch. This code is in a programming language, of course, and it's built line by line. Systems and subsystems are built from smaller components. Systems usually integrate with other systems, and integration is the act of assembly and testing at these various levels. And a pyramid is a metaphor we could make some use of, perhaps. Building subsystems from components is integration in the small. Building a whole system from components and subsystems we could call integration in the large. Building a system of systems, integrating one system with perhaps many others, we could say is integration in the very large. So integration isn't just a single step, it's an iterative, incremental process throughout a project. Now, when we do integration, our goal primarily is to show that components work together to achieve some goal, whether that goal is to move some data in a database or to deliver a user journey or an interface between a system and business partners, banks, and so on. And the areas we focus on when we're building and testing are things like the handover of control, where one component hands over control to another. So a menu system might hand control over to another application. Messaging between components is obviously a situation we have to deal with at times. We build systems out of components that collaborate. So there's a notion of collaboration that we should look at too. And needless to say, there's the transfer of data from component to component, from system to system. These interactions, even with components that are the size of systems, it's the same pattern again and again. Now, the big area of concern in integration is this idea of consistency across components. Do components use and reuse, do they create and read data in a consistent way? That is, are they using the same units? So are we using dollars and cents in all our systems, or euros and cents, or pounds and pennies? Are we using kilograms, meters and seconds, or are we using miles, pounds and so on? This idea of consistent use of data and interpretation of data is critical to integration working properly. Of course, we need to deal with valid data, and data captured in one component might be reused in another, and we have to check that the validation rules as the data is captured are consistent with the processing capability of the components that use that captured data. So this consistency is critical as well. Drifting into security, you could easily see that the security precautions taken in our code need to be consistent across all the components for them to actually communicate with each other at all. There's other things we could look at, but you see the pattern. It's about consistent usage of data, consistent behaviour across our integrated systems. Now, integration in the large, as I will call it, focuses a little bit more on what you might call entity life histories or user journeys. The handoffs across systems, the handover of data across systems, are these things consistent, and do they work reliably? We might have to track the life history of a customer or a product, or the money and other data. In this way, we use reconciliations quite often to check the consistency across databases, systems themselves, as well as components. Integrated systems have to balance. The money has to add up, if you like. And once we get into integration in the large, we're also drifting into areas of non-functional requirements, like availability, reliability, and management, because components and systems fail and must have recovery processes to deal with accidents if that's what is happening. Now, when I talk to people in projects, especially larger projects, and I ask them, what does integration mean to you? What is integration testing? Who does it? When does it happen? Every organisation sees integration as a problem, because integration bugs are found in areas people weren't looking for. So system testers quite often have a challenge of integration bugs stopping them testing effectively. But I want to suggest that integration problems, integration bugs if you like, they're a symptom, not the problem itself. They're a symptom of what essentially could be called poor communication between the developers and the team building that software. But why is this? I think that the reason is integration is pervasive. It's from the second line of code to the last acceptance test. It's all pervasive. So all testing has some aspects of integration. But the problem is that we write requirements in the form of features that users would recognise and use. And we don't talk about integration in our requirements. So integration itself doesn't get covered very well in our functional testing. We treat it as it'll work out, it'll be all right on the night. If I can get my features working, then integration must be okay. This isn't a terribly safe or engineering or scientific way of progressing. What tends to happen is integration risks fall through cracks in our organisations. And far too often people rely on the next test stage to find the problems that I might find difficult to find in this moment. So people rely on the next test phase to find problems. But in the next video, we're going to look at integration testing in the small, usually performed by developers. If you want to know more about the concepts I'm talking about in the Glossary of Terms videos, it will probably help you if you take a look at the Leadership in Tests online class that I created a year or two ago. It covers some of the topics in more detail and obviously provides more of a structured approach to explanations of the concepts, and also gives you some idea of how to do some of the things that I talk about. I hope you can take a look at it and get value out of it. The link is below, bit.ly/leadintest.